So this is section 7.1, and we're starting here because this is a really relevant, useful topic. So I really was hoping to get you engaged at the beginning with something that seems really useful. The calculus that we're going to do, it's going to be a lot harder to think of how that would be of use to you. So this is going to pull in a lot of prior algebra knowledge, but be reassured that I will be bringing in any algebra review that we need as we go along. So the first couple of chapters of your textbook have all the algebra review materials, and I will be bringing them into our work as we need them. So I always will tell you what the objectives of the section are. So this section has 8 objectives, so it's pretty long because it's a big introduction to this topic. So it's called Graphing Linear Inequalities into Variables, and Chapter 7 is about linear programming. So the big topic is linear programming that we're going to be learning about in Chapter 7. And we're going to review this algebra of identifying a linear inequation and inequality, graphing lines, graphing a system of linear equations, solving systems of linear equations, then bringing it into the business world, finding break-even point given cost and revenue functions, and then we're going to graph linear inequalities in 2 variables. So we're building and building up to the topic of linear programming, and it needs all these prior skills. So then we're going to graph the solution set of a system of linear inequalities, and then we're going to solve applications using those. So linear programming as a topic is really useful. It can help make decisions about how to use your resources best. So if you have any kind of limitations on time, space, number of employees, anything that's limiting you, you take those into consideration to make an optimal business decision. So here's a simple example. If you have a small shop and you assemble chainsaws and you assemble wood chippers, but you have a maximum of 48 hours available each week, and the profit on a chainsaw is $150 and the profit on a chipper is $220. So the question is, how many of each should you assemble to maximize your profit? One of my favorite examples is if you have a bakery and you're making cakes and cupcakes, and you have 2 processes, you're baking and icing, and you only have 2 people and they only have so many hours, and you know what the profit on the cake is, and you know what the profit on cupcakes is, and so you can figure out what is the best blend of cakes and cupcakes to make to optimize or maximize your profit. So that's what we're trying to accomplish. So we're going to start by doing things that don't seem related to that, and then we're going to build them up into the entire process. So first we need to be able to identify a linear equation. So know that everything in chapter 7 is straight lines. We're only working with linear equations. Well, that seems kind of limiting, and it is, but it turns out that lots and lots of real life scenarios are described by straight line relationships. So think about how obviously this process could get much more complicated with more variables. Suppose you have a process with 15 different steps, and suppose you have 12 different products. That's a lot more information that has to be accounted for. And so clearly, in order to do the linear programming process for an actual business case, you'd need a computer. So what we're doing is learning how to do it for a really simple scenario with just usually 2 things or maybe 3 things, and learn the process and the idea behind it, so you could see how you would then use that to do computer programming modeling of this scenario. So typically the 2 variables that we'll use are x and y. And in order for an equation or an inequality to be linear, we look for, well, hopefully you remember this y equals mx plus b guy. Now let's talk about all those letters briefly. So the x and the y are the variables. Well, then the m, recall, is the slope. And for a particular situation, that's going to be a number. It's a letter here because we're talking about all the linear equations in the world. And then b, recall, is your y-intercept. That's the y value when x equals 0. So if your equation can be written as y equals mx plus b, then it is a linear equation. So let's look at some examples. If I have y equals 2x plus 3, that one's really easy to see because it matches up exactly to the shape of what we were given as the model. So the m is 2, the b is 3, and we can clearly see that this is a linear equation. Well, if I subtract 3 from both sides and write y minus 3 equals 2x, this is still a linear equation because it can be written as y equals 2x plus 3. So we could also have a linear equation where we have all the letters on one side. We might have y minus 2x equals 3. Well, that's still a linear equation because it can be written in the form y equals mx plus b. So let's look at some of the important features here. Y and x have no exponents on them. So there's an invisible exponent of 1 that we don't see because we don't write exponents of 1. It's just kind of understood that if there's no exponent written, it's a 1. So the x and the y both have exponents of 1. Only adding is going on with the y's and x's. There is no multiplying of x's and y's. And the m is whatever number is multiplying the x when the y is all by itself on one side. Okay, so quick review of linear equations. Then inequalities is if we put one of the inequality symbols between the two sides. Now it's an inequality. And this is a linear inequality. So then we could also have the or equals to. So this is less than or equals to. And we could also have greater than or equal to. So this first guy is called a strict inequality, where the or equals to is not included. Generally, when we are working in linear programming, we're going to be seeing inequalities with the or equals to, so expect that. Okay, so that was identify a linear equation and a linear inequality in two variables. So all the equations you're going to write and all the inequalities you're going to write in this whole chapter are all going to be linear because the title is linear programming. Okay, then graphing lines. We're going to go back to section 2.2 to remember about graphing lines. And a line has this distinguishing characteristic. As x increases by 1, y increases by a constant amount, m, the slope. So if we made a little table of values and we said, let's have y equals 3x plus 5. When x is 0, y would be 5. And then see that when x is 1, y is 8. When x is 2, y is 11. So see that we're adding 3, the slope, each time x increases by 1. So that's really the meaning of the slope, is how much does y increase as x increases by 1. Okay, so let's have another example here. of y equals 2x minus 1. So make sure you label axes on your graphs and use a ruler to make your lines. So let's start with when x is 0, and we'll get y is -1, so that means the point 0, -1 is on our graph. You could also just look at the equation of the line, and if you recall that this is the b, the y-intercept, you could just graph it from there. So then when x is 1, y is 1, so the point 1, 1 is a point on our graph. Then if we have x is 2, we'll get y is 3, so the point 2, 3 is on our graph. And then let's do one negative number just to make sure that we're graphing correctly. So if I put -1, I'm going to get -3. So -1, -3. And then use a ruler to make very straight lines. I usually make enough dots to fill up the entire grid to make sure I'm making a very straight line. And here's the line, y equals 2x minus 1. Okay, so if you have any questions about that, we do have the Algebra Support Center, can help you on the algebra issues you might run into. So they're available for you. Now recall that the slope of a line is y2 minus y1 over x2 minus x1 if you have 2 points that are on the line and you label their coordinates x1, y1, and x2, y2. So the slope of the line we just graphed, just for hex, let's use the formula and use the last 2 points, 2, 3, and -1, -3 to find the slope using an equation. So it's the second y value minus the first y value over the second x value minus the first x value. So -6 over -3, or 2. But we also could have just looked at the formula and seen that the slope is 2. And then let's also look at the graph, the picture of what we're talking about. And if I start at one dot that's on the graph and I go up 2 and over 1, I get to another dot that's on the graph, up 2 over 1. So that's the characteristic feature of this graph with a slope of 2. Okay, so we just practiced finding the slope of a line through 2 points, so let's practice one more. I have m equals the second y value minus the first y value over the second x value minus the first x value. So I'm going to have -4 over 11, and usually we put the negative out in the front. It's not incorrect to have it in the top. It is just kind of bad math grammar to leave a negative in the bottom. So we would say the slope is -4/11. To get from one point to the next on this line, you go down 4 and over to the right 11 to get to the next point on the line. Okay, so there's 3 forms of equations of lines, and forms in math are just kind of templates or models. And there's 3 different ways we write lines, and there's reasons for each of the different ways. They're each useful in different situations. So if you're drawing graphs of lines, the most useful form is this slope-intercept form that I find most people are familiar with and recall from algebra. So that one's really useful for graphing because you plot the y-intercept and then use the slope to identify additional points. So if you have y equals 4x minus 7, you start at the y-intercept of -7. Then you go up 4 over 1, up 4 over 1, and keep doing that and draw your line. Okay, so that's the slope-intercept form. So let's look at this example, and I have always a particular point in mind when I choose an example. So the reason I'm choosing this example is because it has halves. It has 7 halves and a slope of -5 halves. So it will be much easier to graph if I use a scale where each box is 1/2. So 1 box equals 1/2. So sometimes changing the scale of a graph actually makes it easier to put points accurately on that graph. So the y-intercept is 7/2. So we'll count up from the origin 1, 2, 3, 4, 5, 6, 7/2. There's my y-intercept. And my slope is -5/2. So I go down -5, down 5, 1, 2, 3, 4, 5 boxes and over 2. And down 5 boxes and over 2. And there's the points on the line that will help me draw it with a ruler. And there's the graph of the line. And then the equation of the line is y equals -5/2 x plus 7/2. And please get in the habit of boxing or circling your answer. It makes it so much easier to find. Okay, so I'm going to stop here. I like making short videos so that you can watch them in short time intervals and not forget where you were. And I'm going to start with slope of lines in the next video.